Okay, I guess we'll get started. My name is Brian Lockreed. I'm with an organization called IADFI, which is the International Association of Digital Forensics Investigators. First, quick question. Anybody here work in law enforcement? Okay, you're going to learn some of their tricks. Anyways, we're basically an organization of not just law enforcement people, but people that do incident response, malware, and malware investigations, or any kind of digital forensics for that matter. And what we did is we put together a package of software, which is actually there's several tiers to it. What I'm kind of going to do is go through the tiers of that software and talk a little bit more specifically about how we built the facial recognition engines and what we use it for and how it all started out and everything. And my iPad just told me I need to start talking. Anyways, why do we want to do this? Why do we want to do facial recognition? Well, facial recognition's actually been around for a long time. I mean, they had it out in Las Vegas at the casinos like 25, 30 years ago. You know, they use it for other incidences with, you know, law enforcement or investigations, discoveries. So there's a number of criminal reasons why you want to use facial recognition software. We have done cases where we have missing persons that we're trying to track down, and social media is actually an excellent platform for us, because if we know who somebody's friends are and all their followers on Twitter and Facebook and all the other social networks, we can actually monitor pictures that are being uploaded to their social media sites. If we're looking for them, but if we're looking for like a missing person or something, we can help identify those. We've done cases for infidelity, you know, scams, fraud, and probably the tool that I'm going to talk about most today is actually one that's used to do triage for child pornography. So it's the one of the tools that investigators use when they knock your door down and come in and start running the scanners on your computer or computers or media or whatever you have. We're actually one of those tools. So, and also it's been used for, you know, other instances such as human trafficking and things like that. So, a little bit of background here. There's a number of different organizations out there. The Center for Missing and Exploited Children and the Amber Alerts programs and some of those that maintain databases of, well, Amber Alerts is missing people, but the National Center for Missing and Exploited Children maintain databases of child pornography. They have several million hash codes. I'm sure most of you probably know what a hash code is, right? Anybody don't know what a hash code is? It's where you basically take an image and compute like a big checksum across that image, and you can use that image to say this image looks identical to this other image. Okay. We use that database, as well as I mentioned, we have a database of social media image codes, which is a slightly different kind of a hash code set, but basically along the same lines. And we also have a number of tools that we use to index these images, tools that can scan hard drives and other media, and more recently we're starting to develop some tools that can actually scan cell phones and other mobile devices. Okay? Believe it or not, we are now seeing the transportation of images, you know, through cell phones and other mobile devices. Yeah, question?
Are those within a certain range, or you can tap into the network and scan globally?
What was the first part of your question?
Do you have to be within a certain range on RF or something like that?
Well, we're not monitoring your activity. I mean, this would be like a cell phone that's been confiscated.
Okay.
We're not the NSA or anybody. We're not out there watching everything you do. But in the same instance, you could monitor like an employee's computer in a company, and we'll talk a little bit more about that later. Before I move on too quickly, if anybody here has teenage kids that have their own cell phones, sit down with them for 5 minutes because, texting while you're driving is bad, but texting a personal body part image through your phone is way bad. And I've been involved in cases where, something like a 15-year-old girl does something with her boyfriend, and that becomes viral throughout a school, and she gets arrested. And the problem is, it's not one of those juvenile offenses that goes away when you turn 18. Okay, once you get tagged as a sexual predator, that stays with you for life. And unfortunately, I've seen several cases where that's the case. So, if somebody would find her phone or his phone, or if it goes viral, it could very quickly spread throughout a school system. And in fact, we had a case in Indiana about 1.5 years ago where somebody actually committed suicide as a result of images that were on their cell phones. So anyways, just a little upscale on the cell phones there. Okay, so we developed a product called TurboPhoto. We also have one called FaceScan, and what we've done is pretty much merged them together. Now, TurboPhoto is a digital forensics triage tool, which means, and are there any pure digital forensics kind of people in here? Okay, there's a few of you. Okay, a lot of you may balk at this because it tends to violate the rules of chain of custody, but I'll explain how it basically works. If law enforcement knows that there's images within a facility that they're knocking the doors down on, there's a whole chain of custody and everything forensics-wise that they have to go through to confiscate those computers and media and everything else. However, if they can run a triage tool and discover those images very quickly and get them up on the screen very quickly, the probability that they'll get a confession from the bad guy just goes up orders of exponential, okay? Because you're showing it to them right there on the screen. It's not like you got to come back 3 weeks later with some evidence that you recovered in the lab. So that's one of the reasons why triage tools are becoming more and more popular, especially as hard disks get to be larger and larger and larger. People have networks within their houses where they have file servers and media sharing devices and devices driving, large screen TVs and things like that. So, also, like I said, we've used our software within schools. Not so much, believe it or not so much for the students. However, we have had instances where, in one case, a student borrowed a USB drive off of the teacher and gave it back to the teacher, and it was full of bad stuff. So, that's a violation of the law right there. You're not allowed to do that. Could also be used by businesses. We've seen instances where people have been trading it through business email accounts and things like that. Let me jump back to schools real quick. Might be interesting to know that some of the more severe cases that we've seen are actually the teachers. Okay, you think a school teacher, teaching 5-year-old, 10-year-old kids would be involved in things like this? Well, put 2 and 2 together. Teachers like to be around kids, right? So automatically you have, you know, I'm not saying all teachers, but you have the ingredients that, well, now you have somebody that, you know, likes to be around kids. In fact, in Columbus, Ohio, we just had a case where a pediatrician from the Ohio State University in Children's Hospital, and this is a doctor that does oncology, you know, cancer cases with children, and they, so actually some friends of mine did the bust, but they, you know, they found about 60 different images on his computer. It turned out the computer was owned by Ohio State University. So, so it's not just the kids in the school, it's not just the employees in your business. I've seen cases where a business had some computers sitting in the DMZ. Those computers got hacked and were being used to you know, relay child pornography images back and forth to other recipients, and basically it sat there for about 6 months, and the business had really no idea that these images were on their computer. So anyways, getting back to the mechanisms here, we have a database of hash codes for many of the known images. We triangulated that down to about 260,000 of them that we see often. Okay, question?
So those hashes aren't going to help if somebody like resizes the image or takes metadata?
We'll get to that. Yeah, very good question. Very good question. His question was, how does it relate to the size of the image and all that? Okay, that's the reason we use facial vectors. Okay, basically, is that excuse me. Hash codes are only good for a single instance of a static image. You know, they're not going to work if you change one pixel in that image. Okay, that's why we move more towards a facial recognition arrangement. But anyways, using hash codes, we can be very fast. So, for example, the software that I'm going to talk about today that we developed, and we're going to tell you all the tools and everything we use to do it. We can scan a live system, the media, the hard drive on a system, and then actually one of the test systems that we use is a 1 terabyte disk drive with about 65,000 cataloged images. That means those images are in our database. Now, they're not all bad images, but they're just test images that we use. So our application is actually multi-core, multi-threaded. It runs on Windows. Primarily because it's a triage tool, and most of the machines that law enforcement encounter are Windows machines. So that's, but we also have a Linux version, which I'll talk about a little bit later too. But anyways, we can scan that 1 terabyte disk drive, a complete scan in less than 40 minutes. Okay, so you can hardly image a 1 terabyte disk drive in 40 minutes. So it's actually very fast software. Okay. Now, to answer his question, hash codes are good if it's a known image or it's an image that you see floating around on the network. Okay, or one that's been cataloged before, like the Center for Missing and Exploited Children, like they catalog. Facial vectors are a whole lot better because they're like hash codes on steroids. Images can be resized. So, for example, nowadays we see a lot of people that take images, they resize them, they put them on their iPad, or they put them on their iPhone, or their Android, or whatever, and they get resized. They may get, the color palettes may get adjusted. I think I missed color palettes there. You may have a color reduction, so you might go from 16 million colors to, 8192 or something. You may have an image that's been converted to black and white. The other thing that we're able to do is we're able to actually go through a movie, an entire full-length 2 or 3 hour movie, and pick out individual frames of that movie and match those against our database. Okay. Now, one of the hiding techniques that the distributors of this material often use is that they'll take a movie, like, Star Wars or something, and they'll put in the middle of that movie, a 3-minute clip of child pornography. Okay, well, law enforcement's never going to find that unless they watch all the movies that are on this subject's computer, which there could be hundreds of. Okay, I've seen computers with 6 different disk drives, you know, with 400 or 500 movies on them. Okay. So, one of the things that our software does with the facial recognition is that we can actually go through a movie frame by frame by frame and match those frames against our databases. Again, I already mentioned we have some tools that will scan not multimedia, social media sites. No, we don't spy on you. Again, we only use these for certain instances where, you know, we have a particular person that's a missing person that we're looking for. We also have a database of different artifacts and links and codes from these social networks, because people may change their profile pictures, their profile images. So your profile image on Facebook today might be different than what your profile image is on Facebook next week. Now, law enforcement can certainly, you know, get subpoenas to go to Google and Facebook and LinkedIn and everybody else to get access to this data. But if they already have it at their fingertips, it's, you know, it's all better. So, you know, again, it's used by law enforcement and used for digital forensics purposes. Okay, so let's talk a little bit about the facial recognition software. If you don't have any background in it, there's a number of different technologies, if you will. Most of them pretty much evolve around building vectors or building points that are able to, you know, map various locations without a face. And if you just Google facial recognition, you'll come up with, you know, most of these. But the one that we homed in on uses more of this vector approach, where, you know, now you have predefined vectors that can actually map the face. And here you have the advantage that this face can actually rotate, you know, approximately 30 to 35 to 40 degrees in different directions, and the vectors will, you know, can still be transformed accordingly to match that face. Okay, so some of our criteria, if you will, when we built these software tools, we wanted to use as much, you know, open source software as possible, because, you know, we didn't want to have hundreds of thousands of dollars worth of licensing, because our idea was to, you know, make it available to law enforcement and private investigators and other people that use it, you know, as low cost as possible. Part of our requirement was we wanted to have a body of software that could be used on Windows, Linux, and on a Mac. We also wanted the ability to use that same software on iOS devices as well as Android. So, you know, that kind of pretty much narrows it down. And we ended up using C++, because we needed the speed, and we also were able to throw all the libraries that we needed into the blender and actually come up with some products that worked. So some of the back-end tools that we use, somebody asked earlier if we use Python. Yes, we do use Python for some of the database administration, management kind of tools that we use, kind of back office stuff. It's not, we don't actually use Python out in the field for what the investigators run. And we also have some scripts that are written in Perl, as well as some of our web interfaces that are written in PHP. And because of what we're doing and the speed that we want it to run in, you know, we want to build software that's multi-core, multi-threaded as much as possible. Let's have that slide twice. Okay, part of our other requirements was not only do we want to be able to scan images, we want to be able to scan movies, which I said we could do. We also have some sort of what we call plugins that will allow zipped images to be unzipped, where we then scan, you know, all the images that are inside of that zip file. We can also scan compressed images that are in different formats. We also can handle various levels of encryption, primarily XOR is probably the one that we use the most, but we have some work in progress that'll do some other things. And the other thing that we did is we built a tool that will actually scan the system and pick out the images that contain a face. So immediately we can rule out, all the pictures of bunny rabbits and Niagara Falls and all that kind of stuff, and actually home right in on just the files that have, a face. And we actually have a prototype in development that will say it has to have 2 faces in it, or 3 faces, or actually be able to pinpoint. So we can just start flashing those on the screen until the investigator sees what it is they want to see. Okay, so we did some Googling and came up with a whole bunch of different libraries, many of which worked and many of which didn't work, and that's all part of software development. But here's kind of the punch-out list of what we ended up with. There are some other ancillary ones too as well, but these are the primary ones. We use live FFmpeg for doing many of the actual image manipulations themselves. We use live EXIF to look at the EXIF data inside of JPEG images. And we actually had a special case that we were doing where, and when I start talking about our web interfaces, I'll elaborate on that a little bit more. But the idea was they wanted to know, based on GPS locations, images that were coming from a certain GPS area. Okay? And there was also an instance where they knew that one of the photographers that was making these images was using a certain camera, and we could detect the camera's model number and serial number out of these EXIF images. Another package we use is called OpenCV, computer vision package from Intel, which is open source. And another one we use is called TBB, which is our multi-core, multi-threaded library that we use. And then we also use the C++ library called Boost. Does anybody ever use Boost? Anybody here a C++ programmer? Okay. Well, if you're a C++ programmer writing on really any platform, take a look at Boost, because Boost is a library of a lot of different routines that you just need, like regex expression handlers and things like that. Okay, so live FFmpeg wraps the functionality of the FFmpeg program, and so it's basically we can call it from our application just like you call the command line interface. And there's the link to the GitHub for that. Okay, live EXIF, it's the exchangeable image file format, and I won't go into all the details, but you can take a look at the source code there. Okay, OpenCV is a open source computer video application, which is actually created by Intel, and there's the website there where you can get that. And that's part of what we use to extract the frames out of the different movies. So it'll handle different video formats, and we can go in and pick out the different frames, as well as the part of the facial recognition. The other package we used is called TBB, the threaded building blocks, that lets you easily write parallel C++ programs, and that's also another Intel product. And now, just because it allows you to write parallel C++ programs don't mean you just take any arbitrary program and plug it in. Your program has to be pretty much written like it's going to be threaded code, at the get-go. So what we do is we have a number of different functions that or I should say not functions, but operations that we know, when we first read the image in, we do this, we do that, we do the other thing. We're able to parallel those through the system while we're using, the computer has 4 processors, we'll use 4 processors. If it has 8 processors, we'll use 8 processors. We're also looking at using some of the graphics processors as well. Okay. Keep in mind that when you're writing a tool, which is a triage tool, you have no control over what computer this is running on. Okay, because you're giving a USB stick to a law enforcement person who's breaking down your door, plugging this into your computer. So, you can't. Ideally, we would have wrote the whole thing 64-bit, but you can't do that, right? Okay, so the TBB, there's the link for the threading building blocks as part of the multitasking software as well. So it allows you to write scalable data parallel programming, has the mutual exclusion built in, has a task scheduler that handles all the threads, all the multi-core, handles the memory allocation for you, which is a little tricky in a multi-core environment, and also has ways of manipulating vectors and mutexes and things that we're able to use with some of the vector processing that we have to do. Okay, the Boost C++ library that I mentioned earlier, it has just thousands of routines. I won't go through all of them, but if you take a look at boost.org, you can get a pretty good menu of what all the different routines are and what they do. So like I said, we use some of the different regex expression evaluators and different things. And there's that's kind of the, yeah, there you go. That's the URL right there for Boost. Okay, so some of the challenges that we ran into. As I mentioned earlier, 32-bit versus 64-bit. We'd love to have the whole thing 64-bit, but we can't do that. At least on Windows, the way we're doing it, we can't do it. We have built it both ways. Obviously the other challenge that you run into is you don't want to be linking to a whole lot of different DLLs and things that Microsoft can come out next week and change, and you find out your software doesn't work with those anymore. So we pretty much, with the exception of just a couple of DLLs, we pretty much build the software to be, a standalone item that can load into the machine and run. Doesn't rely on anything external. Certainly, as I mentioned earlier, some of the threading multi-core issues were a little bit tedious since we're using existing libraries that were not necessarily written to be used in a multi-core, multi-threading environment. It's a little bit tedious to throw everything into the blender and say, oh, you're going to end up being a multi-core application. Debugging can be a little bit more tricky when you're in a multi-core environment as well. So for the most part, you say, I got one core I want you to use, I don't want you to use any more, and then you do your debugging until you get it all working right. Like any software development, we had to go through the whole cycle of testing, module level, unit level, regression level testing. And then there's always the curse of the next version of Windows. There's multiple versions of Windows out there, and there's 32-bit and 64-bit, all that kind of stuff. So, we have to create one executable image that hopefully runs across all these different versions of Windows. Okay, so moving forward, some of the things we're going to do. More social networks, be able to monitor images that are shared across different social networks, and we actually have a whole other product that we put together for that, as well as some of the cloud services, Dropbox, SkyDrive, Google Drive. We want to add more artifacts in our database from One of the things that's not being recorded by some of the, I can't say who they are, but some of the social networks out there is they sometimes strip out some of the EXIF information of images that are being uploaded, and that can become valuable information to us. So we're working on some things to allow them to keep that. Also, because of the way that we do our database collection, see, law enforcement, if they find new images that we haven't seen yet, they can submit those hash codes and those facial vectors and everything to us. Likewise, we can get updates from other organizations that collect this kind of data. So it's a very distributed kind of an environment, if you will. Mobile apps, as I mentioned earlier, we haven't done a whole lot with mobile apps yet, other than we work with like Celebrite and some of those, where once the phone has been basically copied, file structure and dead space and all that's been copied over to another device, like a hard drive, we can then scan that data just fine. But we don't have any apps that necessarily run on the phone as a native app. Okay, social media stuff. One of the things that we then did, kind of the next phase, was we created what we call TurboPhoto Web. And what that is that's basically the same package rebuilt on a Linux environment, a LAMP environment, that allows images on websites to be scanned. And they can be scanned, bulk, batch mode, every week we go out and scan the whole site, or they can be scanned almost in real time while they're being uploaded to the website. So, with that, you can scan any kind of a cloud-based service, website, a backup service, cloud-based backup service. And with that, we can use the image hash codes as well as the facial recognition databases, as well as the frame-by-frame movie scans that I talked about earlier. So, who would use this? Well, anybody running a large web hosting facility, for example. Okay. There's, currently there's no laws in place that say they have to look at anything that's being uploaded. However, the penalties can be pretty severe if they get busted for having child pornography on their customers' computers. Not only the customers get busted, but the web hosting company, has to then defend themselves that, well, we don't look at any data out there. What do you back the data up? All that kind of stuff. Okay, so a little bit of kind of put things in perspective. I assume that you guys don't run websites like this. But Facebook gets about 350 million new images a day. Okay, so an application like this could, we don't do Facebook, but an application like this could certainly scan every image as it's uploaded. Instagram gets 45 million new images a day. YouTube gets 100 hours of video every minute. Okay, so by being able to actually scan video files, we could then pick out any video file that might have contraband loaded inside of it. Twitter, I couldn't get accurate statistics for the rest of these guys, Twitter and TwitPics and all that. Tumblr, we have already seen instances of child pornography on Tumblr several times, and they keep getting their wrists slapped, but sooner or later, somebody's probably going to come down on them. And again, you got hundreds of other photo sharing sites out there, like Flickr and Yahoo Videos, and Kodak, and everybody's got a photo sharing site. Now, the other thing that we actually ran into, which might be more interesting to some of you guys that do malware kind of investigations, is you can actually embed malware inside of images. How many of you knew that? it's kind of a recent discovery that was made in the last few years, where people were starting to detect that because you can have text embedded inside of an image, you can actually have parts of your malware scripts living inside of EXIF tags and text descriptors and things like that are inside of like JPEG images. Well, we're already ripping this stuff apart as it comes in. So it would actually be very easy for us to have a dictionary of known malware, for example, or known parts of various scripts that are containing malware, and be able to detect that on the upload side. We've also seen XORed scripts that are superimposed inside of images using a whole bunch of different things, really. XOR kind of encryption, as well as steganography and really any kind of encryption method. I mean, once you got this image, you got lots of bits to play with. So you could put inside that whatever you wanted to. Now the beauty of it is, from a hacker standpoint, is how many of your firewalls and stuff are taking a look at any images that are coming down. If this thing says icon.gif, they will let it through. It's an icon off of some website. If it says ebay.gif or twitter.gif or whatever, you're going to let it down, right? And so there's now a lot of possibilities here. Now, it doesn't include any facial recognition, but there's still, there's still opportunities there for a scanner that could pick out that malware from images. Okay. Does anybody have any questions at this point?
Yep.
Yeah.
So, you said the tool's primarily for a triage perspective, right?
Well, the triage tool is.
Right.
We also have the web scanner as well.
Say you have a situation, post, you've done an acquisition, you get in case, right? You got e-files. Does the solution have any capabilities of scanning those e-files?
Well, yeah, you could mount an e-file as a disk drive.
Okay.
Once you mount the e-file, the E01 file or whatever as a disk drive, we
Do you have
scan it.
any scripts or anything with in case that?
Nothing built in. See, keep in mind, we're actually pre-Encase, right? Encase is phase 2, we're phase 1, right? And, I mean, in a triage situation.
Yeah, I'm
Right.
in a situation where I'm looking at a global company, right, doing an acquisition, right, and they're making sure everyone can get the e-files. You don't have the machine or anything like that. Remotely,
Right.
not a communication. So I'm just primarily post, right?
Yeah. No, what he's getting at is Encase basically creates like a big container file of, like a DD image almost, with checksums and lots of other things in it. But there are tools out there that will let you mount an Encase container file as a disk drive. So once it looks like an X drive, we can scan it. We don't care what it is at that point. Likewise, we've done the same thing even with backup container files. So we have backup container files from trying to think. Nero, I think Nero backed it up, and some of those that we've done the same thing now. Yeah, question? I didn't catch all that. You want to?
To answer his question, it's a P40, but P for add-on for Encase Enterprise 6 Plus, mount images,
Right. You can buy an add-on. I think there's actually Linux utilities that do it for free. So you don't need to buy anything, because we run on Linux as well. So we also run in a virtual machine. We can run on a virtual machine just fine. So believe it or not, the multi-core, multi-threading actually works. But anyways, we also run a network called InfoSec Nash, which collects a bunch of information, security information, or I'm sorry, It's kind of like a Twitter on steroids for information security people that you're free to join. Just go to this, lost my pointer. Just go to this website here, /invite. And we use the Yammer network. Everybody familiar with Yammer? So we have our own private Yammer network, so we have to send you an invite. You can't just join the network. You can only join it if we send you an invite. But we actually we monitor about 6,000 different InfoSec blogs and InfoSec and digital forensics blogs. And we post about 300 to 400 new links a day. We don't post the actual news articles. We post links to the blogs. But the reason we like Yammer more so than some of the other social networks is, well, A, it's private. So, you can discuss things that you wouldn't normally discuss on Facebook or Twitter or whatever. But they also have some real nice mobile applications where you can get, basically a streaming list of updates that are coming through. A lot like Twitter, but you can also go in there and bookmark things, and you can tag things and catalog things and do all kinds of other fun stuff. Yammer is actually a company, I think, that Microsoft bought a few years ago. So it doesn't send you email every day unless you want it to. There is an opt-in to send a daily summary through email. And but it is nice on things like iPads and iPhones and Androids and things. So okay, any other questions? Yeah. We got about 10 minutes left here, and since I'm actually a college professor, I don't mind questions, so go ahead, sir.
Do facial vectors change over time with age? So if say a girl went missing when she was 10, we had a picture, but now she would be 20, could we scan for her kind of thing?
The answer is yes, yes, yes. Keep in mind, there are application software packages out there that do age elevation, or whatever you would call it, right? Where they know they can predict what she looks like 10 years from now. So given that information, you could just as easily create a set of vectors from the original face, the 5-year, plus 5-year face, plus 10-year face.
And similarly, after death and decomposition, could you compare a corpse maybe and determine the original face?
We've never been asked to do that, but if the forensics people on the biological side were able to come up with, so you can hand create those vectors. You don't have to just scan a picture. You can create those by hand, and then like one of the tests that we use in development is we got a whole slew of monkeys. We got all the cat pictures, right? We got lots of cat pictures, and we got lots of monkeys, and they shouldn't match, right? And they don't. We also have a generic routine that says, is this a human? So we can, we take it, we crank it down to the point that says, and that's where we do where we can scan an entire hard drive and say, I just want to see the pictures that are people. So, forget about Niagara Falls and all that kind of stuff. Question?
Could you maybe talk a little more about the facial recognition images you see out there and what the differences might be or anything about actual facial recognition?
There are a whole number of different packages, but there were only probably a handful of the free ones. I mean, the open source, I don't want to say free, but the open source ones. There are some very elaborate systems that you can pay for, but because of the environment that we are in, we didn't want licensing requirements where, we'd have to. What's that?
What are the free ones?
Boy, I don't remember off the top of my head. It was a couple of years ago we did the Googling. But the other criteria we had was that it had to be able to run in a multi-core environment as well. And that's the open, because the open CV stuff was Intel, and Intel also made the TDD package, right? The two of them seamlessly work together with, like zero modification on our part. But, I'm sure it wasn't just me that developed it. I mean, there were some other developers that worked on it as well. So if you want to send me my business cards up here, if you want to send me an email, I'm sure we have a list in Evernote somewhere of all the different packages we looked at. Let's go over here. Yeah.
You talk about the hashes of known files that are known bads.
Yes.
I mean,
Those are static hashes.
yeah, are they, is that considered proprietary? Is that considered private? Or is that something that's published? Because let's say that maybe I've mapped out 10,000 hard drives, and I still have MD5s and SHA-1s of every single file I've ever seen. I mean, wouldn't that, to the public, wouldn't those be beneficial for me to be able to go and use those MD5s? Or are they kept private because of their...
Well, I would think so. But for some reason, some of the, I don't mention their names, but for some reason, some of the organizations like to keep them private.
Okay.
Now, since we're working with the investigators directly, we get those coming in. That meaning where we get our, we don't sit around scanning child porn all day. I mean, that's not where we get our hash codes from, right? We actually get our hash codes submitted back to us. Once people start using our tool and they see how fast it is and everything and how beneficial it is, it's in their best interest to give us hash codes.
Which, I mean, if I happen to be a forensic specialist and well vetted in the community, which organization do you join to where you could get that list?
That's ours, IADFI.
Just ask.
Yeah. But like Encase has a library that they've collected over the years, right? I think FTK, do they have one too? Maybe. Okay. See, we're not all that interested in hash codes. If you got some, I'd love to have them. We're more interested in the facial recognition because that's what separates the static images from the dynamic images. Okay. Any other questions? Yeah.
I have a question.
Oh, you have a question? Oh, I thought you were giving me the 5-minute warning. I'm sorry. Go ahead.
So you developed this application, and for your purposes, you use it to detect child pornography.
Right.
But let's say that I work for an organization that would also benefit from being able to scan images and do facial recognition and hashing, but that wasn't, child pornography maybe wasn't my mission. So is what you wrote available for me to use?
Yeah, we can talk about it. Yeah. Okay. Yeah, it's not open source. Right. Yeah, we can talk about it. And part of the reason is exactly what he pointed out, is that, we're collecting hash codes from law enforcement and these different agencies.
Well, no, I would be building my own hash library, right? Just the application.
We actually have a tool that does it. We'll scan an entire hard drive and hash everything on it. So, yeah, I mean, we can, but then that's the easy part, right? It's just a hash code.
Right, but say if I was hunting terrorists.
Right, exactly.
I wouldn't need your hashes. I would be building my own hashes, but I would certainly need your application.
Right.
Right.
Okay. Question?
Talking about the data forensics, do you do any raw data translation into facial vectors?
What do you call it, raw data?
So, just pure data off of a hard drive, I'm not going to say unformatted, but not from a file paper.
As in discovery, as in looking for things?
Like Slack space and things along those lines.
Well, there are a number of tools, a number of the forensics, distributions out there will scan the Slack space, and if it looks like an image, calls it an image and creates a file, right? We can then run against that collection of images and say, yes, it matches, or it doesn't.
And if you're just wanting images, there's ones that are open source that you can run.
Like DEF.
Like designed if your SD card gets and gets.
So I guess I'm thinking more along the lines of how much of an image do you need to create a facial vector?
Well, you need the face.
If you have a broken image.
Just the one.
You just need the face. That's all you need. So you need enough of the face that if, like for example, our generic software that identifies it is a face, and not a monkey, and not a rabbit, and not a cat, okay? if you could, if you say you find the GIF header or the JPEG header or whatever, you use a little bit of regex on that and say, yeah, this is a header. It's a little more difficult, I think, to figure out where the end of that is. But you could chunk it in such a way that you then run the application and say, does this match? No. Well, chunk it a little differently. Does it match? No. See what I'm saying? So, in theory, yeah, you could do that. The problem is we're not an API. I mean, we're not, you would have to have a collection of images and then say, either go scan this entire hard drive or go scan this directory, or, you know what I'm saying? We're not going to go unravel the dead space for you. You're not the first person that's asked for that, by the way. But, that's where you get into encase and let those guys do what they do best, right? They do that stuff. So once they've collected that dead space and they've identified it as an image, we'll be more than happy to take a look at it. Okay. I think we're down about 5 minutes here. Any other questions? Yeah.
Does it also work on illustrations? Could facial rec Mona Lisa or Jessica Rabbit and look for strange images based on those?
Well, Mona Lisa is a bad example because it looks like a photograph, yeah. And that's one of the problems with using facial recognition as a security tool, is that all I gotta do is walk in there with a photograph of you and I'm in, right? As long as that photograph's good. And in fact, somebody just broke the finger, what's the finger scanner
Yes.
on the iOS. Somebody just broke it by basically taking if I can get a fingerprint off of a glass, normal everyday forensics, and they have some method that, 3D printer or something that prints it out in such a way that I can now break into your phone, right? So, it's the same problem. That problem doesn't go away. If I've got a picture of you, and in today's world, I use a 3D scanner or a 3D printer and make it look like you, right? And, you're going to bypass any kind of facial recognition devices that are out there if you have somebody that looks just like you. Yeah.
What's your data store?
What's that?
What's your data store?
Data store.
What's the database? What's the backend?
On the triage tool, we use SQLite, and on the web application, we use MySQL.
Okay, and you found that best for looking through hashes, or that's just what, did you benchmark and figure out what was best for doing this?
We actually have another database, which is a proprietary database that we're prototyping. Thus far, we haven't found the difference to be significant enough that it warrants, changing everything to make it work. The SQLite database that sits on the thumb drive is about 260,000 images. So SQLite does a fabulous job with that small of hash codes. The web-based application is about 19 million hash codes. So that's a little bit different.
And those are known bad hashes of known bad discovered files?
Yes and no. They're actually they're a whole bunch of things. We have a way of slicing and dicing as well. They're all the known bad ones, plus all the suspected bad ones, and I suspect that a lot of them may actually be some investigator somewhere in New Jersey just scanned the whole hard drive and said, all these are bad. You know what I'm saying? See, you're at the mercy of who's collecting the data at that point.
So by the time it gets to you, everything's lumped together. It's not separated into, definite baddies. This might, different categories of severity, or is it just everything?
Right. Like, for example, the Center for, National Center for Missing and Exploited Children, they have no idea if this kid is 14 years old or 21. You know what I'm saying? 21 is legal. You can do whatever you want, right? Well,
Less than that, Kentucky.
unless it looks like he or she looks like a 13-year-old. Okay, we're out of time, so thank you very much. I got some business cards over here. Okay.